triangle, I'm given a side, an angle in between them, and a side, or a side-angle-side triangle. So I'm going to use the law of cosines. Now, what pieces go in for C, A, B, and capital C? The only important part here we need to realize is that this big C has to be an angle. And so I have to put 42 in there because that's the only angle I'm given. This little c is opposite this angle, so I need to put x in for little c. Otherwise, nothing else matters, just as long as c and c are opposite each other and this big C, you put in the angle. So I'm going to go ahead and label the triangle so we know what we're putting into the formula. I've color-coded things so you can see where things are going very nicely. So I'm just going to plug everything into the formula now. You can do some simplification. 16 squared is 256. 10 squared is 100. This is all multiplication, and a lot of students make the mistake of combining it with this part over here, but this 2, 16, and 10, once multiplied, have to stay connected to the cosine of 42. So 2 times 16 times 10 is 320. And this needs to stay over here. I can combine these two, but not with this. 256 plus 100 is 356. So I can make sure that I have an exact answer. I'm trying to get x by itself. I can just go ahead and take the square root right here. Algebraically, when I take the square root, I do get a plus or minus, but I don't care about the minus part in this situation because I'm solving for a side, and side lengths can't be negative. I do want to note that because x is almost by itself here, I could have just taken the square root right here as well. I'm going to plug the square root of this into a graphing calculator and get the side length. The most important thing to remember when you are plugging this into a calculator is that you need to switch from radians to degrees. Oftentimes, triangle problems ask for the degree measure, and we were given 42 degrees in this problem. On the Desmos graphing calculator, you'll go up to the wrench and switch from radians to degrees. Now you can guarantee that when we type in our answer, we'll have everything correct. Rounded to the nearest hundredth, I get x is approximately 10.87. This answer seems reasonable with the side lengths I'm given, 16 and 10. It seems like this could be 10.87. Another situation I would use the law of cosines is if I have 3 sides given. Here we have side lengths 7, 10, and 8. Those are A, B, and C in our law of cosines formula. The only thing important here is that little c has to be 7 because 7 has an angle opposite of it, and little c and big C must go hand in hand together. So I'm going to label some things so you see where they're going in the formula. Now I'm going to plug these values in. I have 7 squared equals 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of x. In this case, I'm solving for an angle. I'm going to do some simplification. 7 squared is 49. 10 squared is 100. 8 squared is 64. And I'm going to multiply these three things together. 2 times 10 times 8 is negative 160. These things can be added together, but they can't be added to this negative 160 because negative 160 is connected to cosine by multiplication. I get 164 when I add those two things together. I'm trying to solve for x, so the first thing I'm going to do is try to isolate this cosine of x. I'm going to subtract 164 from both sides. And then since negative 160 is connected by multiplication right here, I'm going to divide both sides by negative 160. A negative divided by a negative makes a positive. So I'm left with 115 over 160 equals the cosine of x. I'm trying to find this angle measure, so I need to undo this cosine with inverse cosine. This gets x alone. I'm going to plug this into a graphing calculator. Again, we need to double check to make sure our calculator is in degree mode. That's going up to this wrench and changing this to degrees. Now I can type the inverse cosine of 115 over 160. If you want to find that in the keypad, it's in functions, and you can see that it's in inverse trig functions. Rounded to the nearest hundredth, I get 44.05 degrees. So I'm going to make this an approximate sign.